Assalamualaikum and good day. I am Muhammad Zikri bin Muhammad Arif, metric number MBE1136. I would like to present my individual case study, City Hyde Park Apartment, Chicago, Illinois in USA. This building was designed and constructed by Studio Gang Architects, and the construction was completed in 2016. This building is a 500,000 square feet service resident apartment that is LEED certified. It has all the basic amenities such as supermarket, major retailers and fitness center. It also has a roof deck terrace in which they have green large roof just above the podium. If you see at the sectional cut here, it has 11 levels of living floors with 3 levels of amenities just like any other service apartments. But what is interesting with this building is the arrangement of the facade, which are the balconies at the south bank. With the apartment's facade emphasizes its structure with a playful array of stacked concrete panels forming the columns, base, sunshades and balconies that can be seen in the typical balcony arrangement diagrams here. We can see here up close how the south bank facade look. Yes, it is stunning and confusing, but it all can be understood in the facade breakdown here. The south bank facade can be categorized into two types. One that is attached to the living unit and one that is detached from the living unit. The concept of stacking the balconies is simple, with a straight column stemming up at the center that acts as columns that takes gravity loads to the ground. Also, with that in mind, every balcony does have a transfer column that is also acting as a sun shading device at the balconies. Further to this, I would like to study on the effectiveness of thermal break at the facade, a study on how the arrangement of balconies will give impact to the comfort of the living space. Now, two types of unit were identified, with one that is categorized as attached balcony unit and detached balcony unit. Each unit is then separated into two zones, the balcony zone and the living zone. I would like to start this with the study of natural light level. We can see the stereographic diagram of the solar path throughout the year in Chicago on the left, and the solar window for buildings in Chicago is quite low, hence giving quite a direct low sunlight angle throughout the year. With the two units explained before, the attached and detached, we can see the solar shadow simulated here is that the living zone is receiving quite an amount of daylight throughout the year for this attached balcony unit. This detached balcony unit, however, is receiving quite the same amount of daylight throughout the year, simulated in this slide. But upon further comparison, we can see that there is quite a difference in terms of the daylight level for these two units. We can conclude that the detached balcony unit is receiving a lesser daylight throughout the year. It is also simulated here in the average lux level analysis, in which the detached balcony unit are having a lesser lux level throughout the year compared to the attached balcony unit. Further to the results from the previous simulations, I tried to simulate an insolation analysis in pursuit to see the total radiation level through incident solar radiation. Again, the detached balcony unit is receiving lesser solar radiation throughout the year compared to the attached balcony unit. In regards to these simulations, we can see that the difference between these two units is the presence of the thermal break zone based on the layout. Now, I have come up with 3 proposals to improve the effectiveness of thermal break at the facade. So, the first solution is to compromise the whole building by reorientating it 2.5 degree clockwise to avoid the overheated stress period, which is the harsh solar radiation and possible heat gain from the sun. The second solution that I propose, which is the simpler one, is to have the thermal break at the south bank facade, which will substitute all the attached balcony unit to be detached balcony unit. By doing so, this will improve the comfort of every living unit, but only marginally. We can see that the balcony thermal break zone is an effective solution to improve the building envelope performance. So, let's go to the final proposed solution 3. Two simple approach will be used by increasing the length of the sun shading column to be throughout the balcony, colored in blue, and by increasing the width of thermal break zone between the living and the balcony zone by 600 mm. With this approach, it is simulated in this daylight level comparison that the new optimized layout has significantly decreased the daylight penetration into the living zone. The lux level for the optimized layout is also proven to be lesser than the one simulated using the current layout. And with that, the total solar radiation throughout the year is lesser compared to the current layout on the left. Undoubtedly, the addition of thermal breaks has the potential of improving space thermal comfort, but the magnitude of these improvements will greatly depend on the configuration of the building parameters. With that, thank you.